This is Manoj Yadav and you are watching Mechanotherapy. So guys, today we are going to discuss the various types of fluids. So first of all, we have ideal fluid. Ideal fluid is just a hypothesis. There is no such type of fluid which actually exists. We can define ideal fluid as a fluid that does not have viscosity, that is, viscosity is zero and that cannot be compressed. So those fluids which have the viscosity as zero and which cannot be compressed, that is, density remains constant, they are known as ideal fluids. Actually, there is no such type of fluid. The second, we have real fluid. All types of available fluids that possess viscosity are classified as real fluids. For example, kerosene, castor oil, all these types of fluids are known as real fluids. Then we have Newtonian fluid. The fluids which obey the law of Newton viscosity. So we can say that a real fluid that follows Newton's law of viscosity is known as a Newtonian fluid. Now, what is Newton's law of viscosity? According to Newton's law of viscosity, the shear stress is directly proportional to rate of shear strain. So those liquids or those fluids which follow this law, they are known as Newtonian fluid. That is, if we draw the diagram between shear stress and rate of shear strain, it will be a straight line. Examples are hydrogen and water. Then we have non-Newtonian fluids. The fluids that do not follow Newton's law of viscosity are known as non-Newtonian fluids. That is, those fluids in which shear stress is not directly proportional to rate of shear strain. That is, it gives the graph between shear stress and shear strain, rate of shear strain gives a curve. They are known as non-Newtonian fluids. Examples are oobleck and flubber. Then finally we have ideal plastic fluid. Ideal plastic fluid is a fluid that follows Newton's law of viscosity, but the shear stress is greater than yield value. So that is known as ideal plastic fluid. Now you can see all these types of fluids in this graph. This is a graph between shear stress. On y-axis we have taken shear stress and on x-axis we have taken velocity gradient, that is rate of shear strain. So when we draw the graph between shear stress and rate of shear strain, if it is a straight line, it is Newtonian fluid. It is curved, then it is non-Newtonian fluid. And if it is a straight line and not starting from origin, then it is called ideal plastic fluid. On the x-axis, we have ideal fluid because at this point, the shear stress is zero, or we can say the viscosity is zero. So these are ideal fluids. Ideal fluids are represented on the horizontal line, while ideal solids are represented on the vertical line. Okay, so this is all about today's class. Thank you everyone.